And welcome back, students. We're going to be discussing array parameters in our lesson today. So this is kind of a continuation, a little bit of what we discussed last time. So getting started, you can use both array index variables and entire arrays as arguments to methods, even though they are different types of parameters. We'll first discuss array index variables as arguments to methods. So index variable arguments. An index variable can be an argument to a method in exactly the same way that any variable of the array base type can be an argument. So for example, suppose a program contains the following declarations. Double n equals 0, double array a equals new double 10, int I. If my method takes one argument of type double, then the following would be considered legal. My method n. Since the index variable of the array a is also a variable of type double, just like n, the following is equally equal. My method a3. There is one subtlety, though, that does apply to index variables used as arguments. For example, consider the following method call, my method a of I. If the value of I is 3, then the argument would obviously be a3, because you're just plugging 3 in for I. On the other hand, if the value of I is 0, then this call is equivalent to the following, my method a of 0. The index expression is evaluated to determine exactly which index variable is given as the argument. So if you're going to substitute in a variable argument, so like for example a method a of I, then what you have to do is you would take whatever the current value of that variable is. So if I was, let's say, 10, then a of 10 would be evaluated. Right, entire array parameters. You can also define a method as a formal parameter for an entire array so that when the method is called, the argument that is plugged in for this formal parameter is an entire array. Whenever you need to specify the array type, the type name has the form base type array. So this is how you specify a parameter type for an entire array. For example, the method double array elements given in what follows will accept any array of double as its single argument. Public class, sample class, public static void, double array elements, double a, int I, for I equals 0, I is less than a dot length, I plus plus. Array of I is equal to array of I times 2. And then of course the rest of the class definition would follow. So you're doubling the array elements in this example. Alright, to illustrate this purpose, let's suppose you have some following method definitions. Double A equals new double 10, double B equals new double 30. And suppose that the elements of the arrays A and B have been given values. Both of the following then are considered legal invocations. Sample class dot double array elements A and sample class dot double array elements B. You'll note that no square brackets are used when you give an entire array as an argument to a method. Compare that to, if we just back that up, when we use an index variable. Right, when we did the method call, you'll notice that it was the name of the array, bracket, and then the value. When we pass an entire array, you'll notice that with these, you're just simply passing in whatever the array name is. Length of array arguments. Array type is a reference type, just as a class type is. So with a class type argument, a method can change the data in an array argument. To phrase it more precisely, a method can change the value stored in index variables of an array argument. This is illustrated by the preceding method double array elements that we just looked at. Array type parameter does not specify the length of the array argument that may be plugged in the parameter, and an array knows its length and stores it inside the length instance variable. The same array parameter can be replaced with an array arguments of different lengths. Note that the preceding method double array elements can take an array of any length as its argument. If we just flip back real quick and take a look at that, you'll notice in here with this double array, there's not a definition defined for what is the length of the array. It simply is just called right here with a dot length. Otherwise, you can put an array of size 1, you could put an array of size 10, size 100, whatever. It all would be handled with this parameter here. All right, now we need to discuss a quick pitfall, which is the use of equals and equals equals with arrays. All right, now as we have mentioned, arrays are reference types. That is, an array variable contains the memory address of the array it names. The assignment operator copies this memory address. So, for example, consider the following code: double A equals new double 10, double B equals new double 10, int I for I equals 0, I is less than a.length, I plus plus. A of I is equal to I, B equals A, system out the print line. A2 is equal to A2 plus B2 plus B2. A2 is then equal to 42, system out the print line. A42 equals A2 plus B2 plus B2. So if you run that code as shown, this is what you would get as an output. A2 equals B2, B2 equals 2.0. A2 equals 42.0, B2 equals 42.0. The assignment operator B equals A copies the memory address from A to B so that the array variable B contains the same memory address as the array variable A. After the assignment statement, A and B are two different names of the same array. And this is just like what we talk about with classes, pretty much it's pointing, even though you've made two different quote-unquote objects, they're pointing to the same memory address. Thus, when we change the value of A2, we also end up inadvertently changing the value of B2. Unless you want two array variables to be two names to the same array, and on rare occasions you do want to do this, you should not use the assignment operator with arrays. If you want the arrays in A and B in the preceding code to be different arrays with the same values in each index position, then instead of the assignment operator B equals A, you need to do something such as the following. Int I for I equals 0, I is less than a.length, and I is less than b.length, I plus plus, b of I equals a of I. Now note that the previous code will not make B an exact copy of A unless that A and B have the same length. The equality operator equals equals does not test two arrays to see if they contain the same values. Rather, it will test the two arrays to see if they're stored in the same location as the computer's memory. As I already mentioned, it's a reference issue, and if you use equals equals, it's comparing their memory locations. So equals equals with arrays. So consider the following code. Int array C equals new int 10, int array D equals new int 10, int I for I is equals 10, I is less than c.length, I plus plus, c of I equals I, and for I equals 0, I is less than d.length, I plus plus, d of I equals I. If C equals D, system out print line, C and D are equal by equals equals, else system out print line, C and D are not equals by equals equals. Our sample code will then produce the output. C and D are not equal by equals equals, even though C and D technically contain the same integers in the same index variables. A comparison using equals equals will say they're not equal because equals equals only checks the contents of the array variable C and D, which are memory addresses, and C and D contain different memory addresses. And this is because they're different objects. Different objects contain different, space and memory. So when the computer goes to check those, C and D are not the same thing. If you want to test two arrays to see if they contain the same elements, then you can define an equals array method for the arrays, just as you define an equals method for a class. All right, in the class materials will contain an example one possible definition, which we'll look at here in just a second. So let's go ahead and take a gander over to our different equals here. And so here's an example of how to test if two arrays are equal. So here I have public static void main. I have my int C, int D. Here I am doing my two for loops for C and D to get their values. Here is a equals equals right here. It says test to see if they're equal by equals equals, else they're not equal by equals equals. Equals equals only test memory addresses. Then we're going to use this equals array method here. Right? So it calls equals array of C and D and says they're not equal, or else they are. They either are equal or not equal. Right? And of course, then we just say an equals method is usually a more useful test. So down here we have defined a equals method. So public static boolean equal arrays int I, int b. If a.length does not equal b.length, return false. So that's the first thing it does. It checks the length to make sure that they are the same. Obviously, if the array sizes are different, so let's say you have an array of size 3 and an array of size 5, you automatically know that they're not going to be two equal arrays. So it automatically is going to cancel this out. Right? Then we have down here else int I equals 0, while I is less than a.length. If array A, or excuse me, array of I is array A of I is not equal to B of I, return false. So this set right here is actually testing them for the equality based upon the index value. So it's going to the first index, so it's going to start obviously with 0. So it's going to look in array A. What's the value of array A at 0? Well, if array A is 0, let's say is 1, and the array of B of 0 is 1, well, that's technically true. So it's going to increment I, and it's going to go check the next position. So go to A of 1. Now, let's say it's equal all the way up to, let's say, A of 3. So A of 3, it comes in here, and let's say A of 3 is 7. And B of 3 is, let's say, 5. Well, all of a sudden, you now have two arrays that are different, which means it returns false, and because it returns false, it's going to exit out of this, and it's going to spit right here a false statement because it's a boolean, and if it comes out false, what we end up getting is our else here. If we get it that they're true, that everything is equal, it prints out this true method. Okay, and that's going to kind of about wrap things up, folks. So, like I say, if we just go ahead and just run this demo code, just so you can see how this program works. Let it finish compiling itself here. Okay. C and D are not equal by equals equals. Equals use only test memory addresses. C and D are equal by the equal arrays method. Unequal arrays method is usually a more useful test. Okay. And that's going to kind of wrap it up for today, folks. So, until next time.